Bismillahirrahmanirrahim. Today we will learn that topic that is about how to convert ordinary numbers into scientific notations. These scientific notations are quite helpful in the topic of logarithms as well. So today we will learn that what is scientific notation and how do we convert extremely large numbers or extremely small numbers in scientific notations. So, in just in few words, I want to tell you that what is the significance of the scientific notations. When in sciences we have to deal with either extremely large numbers, like distances between Earth and the Sun, like distance between galaxies, and sometimes we have to deal with extremely small numbers, like mass of electron, charge of electron, or these type of extremely small numbers, and we want to learn those numbers with some accuracy. So for that purpose, we write the numbers with higher powers of 10. So generally, we express or write any number which is a bigger one. Let's suppose A is a number. It will be written as b times 10 raised to power n. So this is a format in which we convert all the numbers, either they are extremely large or extremely small, in powers of 10. Now let me describe what is b actually. So b will be a number that ranges from 1 to 9.99. 9.99 means that b cannot be a double digit whole number. It will be between 1 to 9.99, any number. Whereas 10 raised to power n, in 10 raised to power n will be the integer. So integers are starting from 0, plus minus 1, plus minus 2, plus minus 3, and up to infinity, any number you can take up. But power of n will always be from the integers. It will not be a decimal number, it will not be a fraction number, but it will always be a positive integer. So let's begin then how to start from uh, the very first example, that how to convert large numbers in scientific notations. So if it is a number, you can see that 9, 6, and it contains 6 zeros. Whenever a number is finished, we should understand that this, uh, whenever a number is ended, either we write or we don't write, its decimal is at the end of the number. If it is not mentioned in the number, then it will be at the end of the number. So what we have to do, that we have to convert this decimal right after the first non-zero digit on the left hand side of the number. Means that you will write it as 9.6, and then you will write the number of digits that you move the decimal from. If we count it from right side to left side, 1, 2, 3, 4, 5, 6, and 7 digits we have moved. So you write it as 10 raised to power plus 7. So whenever we are moving the decimal from right side to left side, we will keep the power of 10 constant. Similarly, if you look at the second example, uh, its decimal will be right here, and if we shift this decimal right after the first non-zero digit, so it will be written as 7.86, and we have shifted it how many number of digits? 3, 6, 9, 9 and 2, 11. So you would write 10 raised to power 11 once again, because we are shifting the decimal from right towards the left position, so its power will always be written as constant. So this bigger number is converted into the scientific notation. Similarly, if you take the third example, its decimal will be at the end of this number, and you shift this number at this position, which is right after first number on left hand side, it will become 1.48. And if you just count the number of digits, like 3, 6, 9, 12, and 2, 14 digits we have moved. So it will be written as 10 raised to power plus 40. So this is ordinary notation of writing a number. It is converted into the scientific notation. Similarly, if you take another example, you are shifting the decimal right after the 6, like in this position. It will be written as 6.24 into 10 raised to power. How many digits we have shifted? 3, 6, and 7. So once again, it will be written as. Similarly, we can write extremely small numbers like 0.00000039. So rule is same, but the powers of 10 will be, in this case, it will be negative because we are shifting the decimal from right position towards the left. Right? So what will you do? That you will shift this number, this decimal, right after the first non-zero digit, that is 3. So it will be written as 3.95 into 10 raised to power. How many digits we have here? So 3, 6, 9, and 110. You would write 10, but it will be written as 10 raised to power minus 10. And another example, uh, shifting decimal from this position towards this position. It will make it 7.86. But as we are moving the decimal from rightward towards the leftward, so it will be written as 10 raised to power 3, 6, and 7 minus 7. And finally, if we consider another example, just place another 0 right here, another 0. So you can convert it into these sort of format. We will see that once again, shifting the decimal from the first, this position right after the first non-zero digit, it will become 5.81 into 10 raised to power 3, 6, and 9. So you will write 10 raised to power minus 9. So this video actually explain that how to convert uh, extremely large numbers or extremely small numbers as powers of 10 and into the scientific notations basically. So I hope that if you will do the further examples with your own hands or practice some questions, you will be able to understand that how to convert the scientific notation numbers into the scientific notations. Thank you.